Hey everyone, and welcome to this episode where I want to focus on give you all the lessons I learned when trying to create beautiful UIs using this LVGL light and versatile graphics library over an TFT screen using an ESP32 board. Okay. So if you do not know the library yet, I'm gonna show you here a couple of examples and demos I created with my display. Okay, I started working with this library because a customer told me that he wanted to use this LVGA library over a certain kind of display. Of course, this library contains a lot of examples. It supports a lot of MCUs and MPUs, and they promise that you can use very easily this drawing library over any type of display. So indeed it is. So today I'm gonna show you what is the most important things that you have to take into account whenever you are developing a driver for a new TFT library, which was my case. Okay, so number one is color format. What is color format? It is actually the number or bits or bytes you are going to use with your display to represent only one color. Okay, you must have and be sure that either your display and the library support the kind of color format that you want. This library supports 8, 16, 24, and 32 color format displays, where in each of these bytes you are going to send information to the display using these R, G, and B colors. Okay, in this case we have also this color format, which you have, or it is a bit known, RGBI 565, which means you are going to use 5 bits for red, 6 bytes for green, and 5 bits for blue. Okay, so you are allowed to use any kind of color format. So when using this 8-bit color format, you will have 256 colors. Okay, so there are plenty of colors, but you have to take into account that you will not be allowed to show all the spectrum of colors. Okay, because this is for all the non-colors, and if you are using 16, you will have around 65k different colors. Okay, so there are more information over the colors on your images, on your UIs, but there is a trade-off. Of course, I was using SPI to communicate the MCU with the display. So whenever you are going to send one or two colors, you must be aware that you are sending twice as much information, so the rendering or the drawing is slowing down. Okay, also I wanted to mention this lesson because I was trying to send or to show images. I was trying to send some icons with no background, but actually whenever I flash into the microcontroller these images, I got a black screen on the background. But I removed the background using a tool and then sending to the microcontroller and flashing, but then I realized that the color format was not the correct one. Why? Because you need to send another channel, which is A for alpha, which means it is the transparency. In this case, a RGB, it is using the first 8 bits for transparency, and the rest of them, it was this color format. Okay, so whenever you are trying to send images or show something without a background or with some transparency, you will have to make use of this type of color formats. Okay, now what it is, or the most important thing, it is a buffer. Okay, a buffer and the mode you are going to use to draw. Buffer and a mode. This library allows you to use a full screen and a partial mode. In this full screen, you will have to make use of a buffer which is the same size as your displays. In my case, I was using an 800 by 480 pixels display. So if I'm not wrong, this is kind of 380 kilobytes of RAM, okay? This is not a lot of RAM, but since I was using an ESP32 microcontroller, I only had available 320 kilobytes of RAM. And also, of course, this is all the RAM that I was using for my driver and for all the stuff that the client wants to. So as this was not enough, I had to use this partial mode where the library tells you that you have at least to use a buffer which is a tenth of the size of the full screen. So in this case, I was using a 38 kilobyte buffer. Why this kind of buffer? Because at the end of the day, your display is nothing else than a matrix of pixels where the LGB library is going to tell the screen which color has to be each of these pixels, okay? In order to show something, you have to tell each of these pixels every time what color they must be, okay? So take into account the full screen, the type of your screen, the size of your screen, I meant, and the partial mode. And well, actually, at the end, whenever you were using this kind of rendering or the drawing, LVGL is going to give you a function where you have to draw the pixels with a window, okay? Let's suppose you have a clock here. It is 10:32 and the seconds. Let's suppose it is 10 seconds, and after 1 second you only will have to change this 1 second. So the library is going to give you a rectangle, this kind of rectangle, an area from here to only change this tiny piece of information instead of rendering the whole screen every time, which happens when you are selecting the full screen mode, okay? That is the beauty of this library whenever you're using the partial mode. So you will have to create a function as a developer that receives a window as a parameter, window, and a buffer. This buffer is the one that it's going to be used all across your drawing and all the information you will have to send to the screen, okay? So in this case, you are going to receive, let's suppose you have coordinates 320 and 250, which is the start of this point here and at the end, okay? Another coordinates, let's suppose it is 360 and 280. You will have to receive this kind of information, and you will have to draw the buffer, which is going to contain all the pixel data information, which you are going to receive as a pointer to, instead of showing a 0, showing a 1 or whatever it is, okay? So that is the most important thing whenever you are developing or trying to create beautiful UIs with this kind of versatile library. Oh, one more thing at the end. As I was using these color formats, either using 8, 16, 24, or 32, whenever I was using 8, I had no problems with the endianness of the microcontroller and the TFT, but then I started having problems whenever I use 16. Why? Because of the endianness of my microcontroller. ESP32, I had to swap the bytes every single time I was sending, let's say, this kind of color. Before sending this type of information to the TFT screen, I will have to EF instead of FF. So you must take into account the byte order that you are going to use in your microcontroller and in your screen. Okay, so hope this is useful for you. If you have any doubts, you want to create a beautiful UIs, please let me know. I am Eduardo Garcia. I am an embedded software which has been working on the embedded system for over more than 5 years. So please let me know if you want to create a beautiful UI or create any product. If you want to see any demo, please let me know here in the comments. Thank you.